Good afternoon, guys. So I'm Saravanan. I'm doing PhD in Advanced Semiconductor Laboratory under Professor Xie Hong Lee's guidance. So today we are going to see how to operate the Hall measurement system. So in this setup, we have the PC, where we can continuously monitor the data, and this is the place where we're going to load the sample, and this is the measuring unit, which helps to get the data like current and voltage, and it will be transferred to the system for measurement. So now we're going to see how we're going to use a sample for measurements. So first let's turn on the system, and we have the power supply here. Just turn on. We have to wait for a few seconds. Next is we have the software here. So the software name is HMS 3000. So we have two options, start measurement and exit. So for start measurement, so first always we need to start with IV curve. So in this software we have two different modules. One is measuring the IV curve, next is measuring the Hall parameters. So here, before starting the measurement, we have to make sure whether this PC and the measuring unit is communicated well or not. So for that we have to test the communication. It will show success. So if it shows success, then the communication is good. Now the system is ready for loading the sample for measurement. So now we can see how we are going to load the sample. So we always have a dummy stand. So this dummy stand, you can see we have 1, 2, 3, 4. We have 4 electrodes. So we have to remove them, and we have to replace with the original one. So before replacing, we have to make sure the stand is well kept so that it won't fall and it won't get damaged. So this is the actual sample holder. So in this sample holder, we can see G, A, B, C, D. G refers to ground, A, B, C, D are 4 ports. So with the help of these 4 ports, we will be measuring the current for the applied voltage from the sample. So now we are going to see how we are going to load the sample, pin them, and then how we are going to measure it now. So now we have a sample. So we are going to use this sample for measuring the Hall measurement. And we have a gold covering, and we can able to see how much amount of sheet concentration under the Hall parameters using the system. So first we have to place the sample in the center, and then we have to carefully mount the pins on the surface of the sample. We can see these pins are easily adjustable, so we can easily adjust like this. Like for example, we can use even the tweezer to adjust it. Like this we can take and adjust them, even the lateral and also vertical. So now we are going to pin the sample. For example, I am going to take this pin and place it on surface of sample. Like this we have to continue for the other 3 pins. So now we have the sample mounted. Next step is loading this sample holder in the system. So how we have to load is, we have 5 pins, and 5 pins have to go in this direction. Like this we have to mount it. We have to carefully mount it. We must not give more pressure, otherwise it will break the sample holder. So we can able to load the sample. So the next step is, we have to carefully place this holder inside the system for measuring. We have to slowly move. Make sure these 4 pins are connected to the 4 openings on this structure. Now we can see it's clearly fitted. In case if it's not fitted, it will be looking like this. We have to make sure it's mounting well and keeping them well. So once we place this, next step we have to start controlling the software. So already we have tested its connection is success. Next step is to measure the current. For measuring the IV, we have to make sure some important parameters should be kept good. First is username. You can give as per your requirement. Sample name is fine. The very important is delay time, and then the initial and the final current. So in the initial and final current, we have lots of units like milliamps, microamps and nanoamps. We can choose based on our sample features. In our case, we know that device is having the gold, so it is highly conductive, so it's fine to have a milliamps current. For the applied current, we're going to measure the voltage. Based on this, the system will automatically calculate the resistance. Now we can see how it is measuring. Test is success and measure. So we can see here, as we see in the holder, we chose A, B, C, D. So now it's trying to measure the potential for the current in 4 different probes. So now we can see in the IV behavior, this perfect lateral means the sample that we loaded is conducting. So in place of gold, if you have any other material which has this similar behavior, it means it is having a very good conducting property, and you can able to measure the Hall measurements. One of the important parameters we need to consider is, for any sample that we use for Hall, its resistance should be less than 1 mega ohms. If it's not, then the sample we cannot able to measure any parameters using Hall measurement. So we have to wait for few more seconds. We can able to get the result soon. So now the last measurement is going on. Once we get all the 4, next step will be to measure the Hall measurement. Okay, so measurement is completed successfully. So, and we have a linear behavior. Now everything is fine. So we're gonna go to the next level. So here, the same way we have to use the same delay time which we used for measuring IV, and D is we have to maintain same value. The most important is magnetic field. How we know what is the exact magnetic field is, we to easily refer, we have the magnetic field value here. We have to use the same magnetic field in the same place here, 0.525 Tesla and this one. So we have to make sure that is good. So to give a brief overview, during this measurement we will be doing for 3 times. One is measuring without magnetic bar. The second is we have to place this magnetic field in a specific direction, and the other one in the opposite direction. Now we are gonna see how we are gonna measure it. So first is measuring without the magnetic bar. So first communication test success. First measure. So here we can see AB, BC, AC, and we have this millivolt. This volt refers to the Hall voltage. So we have a specific measurements reasoning began negative. This negative, it refers to the n-type material. So based on those also we can able to understand what type of polarity we have it in the sample. Well, we know it's a gold, so it's either it's negative or positive, or they know it's highly conductive, so it's good. So now it has a good metal property. So now it is showing we have to insert the magnet now from north to south. So in the measurement system we can see we have the north. So from here we have to insert inside. That means we have to take the magnetic bar, and then we have to start inserting. Let me come this side. Yeah. So start from here. Carefully we need to insert it, and then insert inside. North towards south. Now we are going to measure in the sample. So now it's asking us to insert from south to north. So what we have to do, take the magnetic bar carefully outside, and then we have to insert in opposite direction. Carefully we need to insert it. Next is we have to measure now. So we have to remove the magnet. Carefully we need to keep it outside. So okay, now we can have a brief discussion about the parameters that we receive now. So the most important parameters are bulk concentration, which is measured per centimeter cube, sheet concentration, which we call as 2D sheet concentration of charges, it's per meter centimeter square, and then we will be considering the sheet resistance, mobility, and then conductivity. So these are the very important parameters that we need to consider for understanding the material properties. So here we can see 10^23. We know it's highly conductive, so it is obvious that we have a reason to have 10^23, and then we have very good mobility and also very good conductivity. So overall we can say the quality of the gold that we have in this device is really good, and we can able to quantify using the Hall effect measurement system. So this is the brief overview of calculating the parameters from the system. So this is the brief procedure, guys. We can see here it's very easy to operate the whole system, and like for now I have shown the room temperature measurement. We can also do a cryo temperature also. So once you come, guys, we can able to get the liquid nitrogen, and we can fill the liquid nitrogen in this specific place here. So you can show this place, this place, and then we have to add the liquid nitrogen, and we can able to measure a cryo temperature also. So now I'm gonna show how to unload the sample. So we have to take the sample holder. So carefully again we have to unpin. And then keep the holder back in the same place where we have taken, and then replace them with the dummy holder, and then carefully place it back. So So that's it guys, this is the overall operation of the system. All the best. I will show you how to save the data. So we have two options to save. One, we can save directly in a text form. You can create a folder in, I will show in my name. There's one option. Next option is we can save it even through the like a screen print. Just click it and you can save it directly. So you can save it in the same folder. So we can follow the same procedure for the IV curve also. So overall we will get two data. One is IV curve, the other one is Hall measurement parameters. With the help of this you can understand your material properties. So thank you guys, thanks for watching, have a nice day.